Yeah, hi, I'm Tom Phillips, Kansas State University, and we're going to take a picture of me so that I can turn around. I won't pick my nose too much. So I'm going to cover a little bit about the biology of these insects and habits, and can I do that? Oh, lions. Hmm. Oh, okay. Well, will that work also? No, I guess not. All right. So where do these things live? And this is really, one of the targets for this webinar are people who manage grain and storage. This is a fairly large size regional elevator. The same insects we're talking about throughout pretty much will be found in this facility, also in something like a flour mill. You'll get some subset of the group of pest insects. Here's a large commercial high value storage, okay? I believe it's popcorn. Linda might recognize that. And then the same stored product insects go right up into value-added finished foods. So in today's talk, we're mainly going to talk about grain elevators and a little bit about milled products. We're not going to get into the value-added parts. So it's really stored grain as opposed to the general stored products. So insect biology and identification. Quick general entomology on this. The insects we work on and even the mites have a life cycle with different life stages. So the general thing for all the beetles we're talking about, they will have an egg stage, several larval stages, a pupal stage, and the adult. Each one of these can react a little bit differently to pest control, so we need to be aware of that. The ones we're going to be using for identification, the life stages that are most common, will pretty much be the adults. I can say for sure, of the beetles we're talking about, they will be the adults. It's rare that you're going to see a larva that you want to use for identification. You may, if you look carefully, you're going to find some larvae. We also use damage, and so whoever's managing grain needs to recognize damaged grain in general, and then if there's a suspicion of insect damage, that they look for that. So we'll talk a bit about that. When it comes back to the biology of the insects, it can also help identify them. We have a few species where the larvae, the feeding stage, are inside the kernel. And then the majority of our pests are feeding on broken kernels, dust from these kernels, and in milled products, a lot of things. They're called the external feeders. Interestingly, these species tend to be more serious as pests as we move up the value-added chain towards the food warehouse and grocery store, because all of that food, all of that stuff is grain that's been processed and ground up. So the easy part, the hard part is done for them. And a little bit then I'm going to cover just the common pests, as will Linda and Frank. And, but there's actually hundreds, although in general we find maybe up to 20 in stored grain in the north central states. And when you get right down to it, we worry about a dozen or so. Okay, the internal grain feeders, again, this is where the larva, the feeding stage, looks like a little worm, is feeding inside the kernel of corn or wheat, whatever you might have. And then when they emerge, they usually undergo the pupal stage. When they emerge as a new adult, they make a pretty nice hole right through it. That's evidence of an insect damage. You're not always going to see the perfect hole, but they emerge to the outside as a new adult. Really, we have two species that we like to pay attention to, or two or three species. On wheat, it'll be the lesser grain borer, and on wheat and corn, it could be the maize weevil. That would be a big one on corn, based on the name maize weevil, and rice weevil on wheat. But rice weevil and maize weevil look so similar, we're going to group them together. Lesser grain borer, okay? This is a little bullet-shaped brown beetle. Smaller than a grain kernel, so this is wheat in the photo. You can imagine much smaller than corn. I will say that this one generally 99% of the time will not be found on corn, but it is the most serious pest of wheat and rice in the more southern states. This one will lay its eggs outside the kernel, but then immediately when the egg hatches, the little baby larva drills down into the kernel. It's best if there's a little bit of damage somewhere made by the adults. And then that larva completes its development inside, and then they bore out. So you can see these guys close up, making bullet holes in the grain. Here's a little demonstration we did several years back, where we put 100 adult lesser grain borers on a bunch of wheat shown in the jar on the left. We let them go for a week and then sifted out those adults. And you can see 4 weeks later, you're seeing dust. Well, that's the beginning of the emergence of the new adults and also the larvae kicking out the chewed up grain and their frass. But look, after 2 months, then you have dust all over the place. You've got a lot of damaged wheat. And as you go up to 3 months, 4 months, 5 months, it reduces that grain to total flour. We never want that to happen in a grain bin. However, the 28-day thing has probably already happened a couple times based on temperature here in Kansas. So this is a really serious insect when it gets bad. And part of our main thing of our IPM is to not allow it to get that bad. The other internal feeder, rice weevil, and Linda will also cover this as the maize weevil, is a beetle that has its mouth parts at the end of this snout right here. Okay, so as entomologists, these are the ones that we really know as weevils. The other ones are beetles, but okay with me if you call them all weevils. So the mouth parts are there. They chew a little round hole, and if it's a female weevil, she turns around and pops an egg into the kernel, and the larvae develop totally within the kernel, and then emerge to the outside. Again, more of this round exit hole of the insect. Okay, the external grain feeders is where the larvae develop on broken kernels, fine material, flour, and also fungi. And a lot of us don't think of that because we don't always see the fungi until it gets bad. But these insects, in their evolutionary history, a lot of them fed on fungi as a nutritional source. I'm just going to pop off the names of some of the more common ones: the flour beetles, the flat grain beetles, sawtooth and merchant grain beetle, foreign grain beetle. These now are some a little, the last few beetles are not so common. Indian meal moth is probably very common in all the areas we're talking about, and it changes in its importance depending on the product. Book lice, little tiny things. We get complaints about them from elevators late in the season after a real hot summer. And they're just very small insects. Many people call them mites, but technically they're not mites. And then we have some mites that technically are mites. So I'll cover how these appear and what they do. This guy, the rusty grain beetle, is really common in stored grain. Probably in my neighborhood with stored wheat, it's one of the most common insects. Very tiny. So remember this related to the weevil, the rice weevil, and the lesser grain borer. It is smaller than a lesser grain borer. It is flattened in body shape. It is reddish, but a little bit of a light red. And that's pretty much what you'll see. They're fast moving and they show up in large numbers when they're in a bad infestation. The red flour beetle, a very common insect in our milled products, particularly flour, hence its name, is quite a bit larger than the rusty grain beetle. Red again, a little more rounded, not so flat. Again, this one's gonna be noticed because of its level of reproduction, and it will have large numbers in a bad infestation. Now, some common ones that also will show up. This is the sawtooth grain beetle. Also has a close relative called the merchant grain beetle. And the diagnostic thing, the way you can tell you've got a sawtooth or a merchant, is when you look at them up close with a hand lens. They have this sawtooth margin just behind the head on that section of the body, and that's it, sawtooth beetle. Again, an external feeder. Don't want to have too many of them. All right. Foreign grain beetle can be very common on moldy grain. We used to find this one after a rain, if I'm remembering correctly. The hairy fungus beetle, as the name implies, is going to tend to be on moisture grain that has some fungi growing. Again, it's small, red. This one's not rounded, nor is the foreign grain beetle. I mean, it is rounded. So rounded bodies, there are a bunch of them. After a while, you got all these brown, red beetles. Just seeing them is bad. Indian meal moth is, I'd like to say it's our most common stored product insect. People will get this in their homes. It's called a pantry pest sometimes. Major pest of pet food, animal feed, and in grain bins, it's this larval stage shown here in our lab colony on the jar that's laying down silk. Okay, it's the late larval stage. They actually come to the top of the grain mass and they wander around looking for a place to hide. In the process, they're laying down all this silk that then can cause the grain to increase in moisture. Just a nice example of life stages. The eggs are very tiny, as shown here on is this a pointer? No, as shown here on the penny. The larvae are larger, and there's the pupal stage, so they go back down a bit and spin a cocoon, and then we see 3 of the stages in the picture to the right. Sometimes I've gotten calls from people that say they open the bin, and something flew out in their face. Well, if it's flying like that, it's probably not going to be a beetle. It's going to be the Indian meal moth. Very common, not always the most serious pest in stored grain, except I do know that in corn and in some wheat, it can cause that silky layer that really is bad for moisture buildup. Book lice, tiny. Don't have a scale on here, but that's 1/16 of an inch to 2/16 of an inch long. Very, very small, large numbers, no wings, flat, and just zinging around, build up in large, large numbers, so it looks like moving dust sometimes. To be distinguished from something that really looks like moving dust, the grain mites. They're not insects. If you know a little bit about this, it's an arachnid. It's closely related to a spider. So if you're looking at it with a microscope, it'll have 8 legs, not 6. Again, it will be associated with a higher moisture grain, but we have several species. They don't contribute to grain damage, and if you're lucky, the grain inspector won't even see them because they're so tiny. Integrated pest management. So a little bit about this concept. If you're a county agent, you hear us in the universities talking about IPM a lot. It's pretty much the same all throughout agriculture, a little bit different for the stored product and stored grain system. So as in field crops, we like to think of sampling-based approaches to IPM with an objective to reduce insecticide usage. Now again, this will change depending on the value of your commodity and what you're going to set as a trigger for making that decision to use insecticides and so forth. Sampling is not just the insects that we're sampling, but we want to know something about the quality of the grain, so it might be measurements on temperature in the grain and measurements on grain moisture content. So in stored product IPM, we have this multiple component strategy that hopefully will reduce insecticide use, because that's expensive, and also it adds residues that can impact the quality of your grain. And really, we want to collect information and store the grain properly so that you probably won't need fumigation, or if you do, you only do it once and you solve your issue. Because through all of this, one important thing is that when somebody storing grain goes to sell it, they probably don't want to have live insects. The person buying the grain, especially if it's a mill, whether it's a feed mill or a flour mill, or if it's going up the line through the market to different buyers, they're going to use live insects as a trigger for rejecting the load or for charging for fumigation, okay? What we call being docked, lowering the price. So basically, you don't want to see live grain insects crawling around in a sample that your customer takes. You do have a large mass of grain, so once it's in the bin, sampling is difficult and insect control is difficult, but we're going to talk about how to do that. So the basics of stored product and stored grain IPM is in prevention, and a lot of this has to do with cleanliness, sanitation of your grain and your grain bins, monitoring the grain for insects, temperature changes, moisture changes, and then you make a decision. So IPM is really a decision-making process. Do you need to act because you found insects? Maybe that action is fumigating, maybe it's turning the grain and treating it with a chemical, or can you just keep going? And ideally, it's that last part. Pass on the action, we're hoping, and you keep watching the grain. And if there's no problems, you're good to go. All right, so prevention. One of the first things is be storing grain in clean bins. One of the big rules I talk about is do not store new grain on top of old grain. You need to empty that stuff out. Then if you get inside to clean the bin somehow, that's really great because there's a lot of insects living in the grain fragments. Sealing the bins is really a form of preparation for other things. Basically, you don't want any holes in the roof so that rain gets in. You don't want any sort of precipitation, whether it be rain now or snow in the future, to leak through the roof. But you need to seal it also so that you can eventually, you don't completely seal it, but you seal the big holes so that if you need fumigation, you're only going to need a few bits of sealing to do, and then you're ready to fumigate. Residual insecticides, okay? This is a spray which leaves a residue that can kill insects for weeks to months, and Frank is going to go into details about that. But we would spray residual insecticides on the metal surface of an empty bin. We also might apply it directly to the grain as a grain protectant, and this will be done for high-value grains such as seed. Or if there's some decision that you want to spend the money for that, you may need to treat grain with a residual partway through storage as you move it from one bin to another. Common sense, again, like cleaning bins, is store dry grain, okay? Um, Linda is going to go over this a lot with corn because corn in the northern Midwest is not dry enough to store when it comes out of the field in most cases. So the corn has to be stored down properly. With wheat in Kansas, Nebraska, so forth, drying should be adequate in the field, but if it is above 13%, for example, even above 12%, you want to pay attention to how it's being stored. If it's going to be blended with dry grain, which is what many good managers will do, that's one way to get it to a safe, dry moisture content. Monitor and record temperatures, the grain quality, and the pests. Easier said than done, but we know temperature. Many people with well-equipped bins will have temperature cables where they can read the temperatures and keep those records. Also, grain quality. You should get a grade on your grain before it goes into storage. You should know, and ideally, if it's been recently harvested, it'll be the highest quality it's ever going to be until later in storage. So we know that with wheat, it will be graded right away when it's purchased. You'll know how much fine material, you know what how much damage there is, and so forth. So it's test weight and it's IDK in wheat. It's going to be BCFM in corn. Looking for a nod to the corn people, and all that stuff. Okay, so broken corn and fine material, bad stuff. Aeration, okay, I pick the number 60 Fahrenheit. Insects are not real active below 60. They're not dead by any means, but the eggs take a long, long time to hatch. The larvae don't develop very much, and the adults just sit still and they might lay an egg every week or so if you're lucky. They're not killed, remember that, but it slows down their population growth. So it's really important, if you have it, to use aeration and use it properly. Such as right now in Kansas, it was in the low 50s last night. It's not a bad time to fumigate, but don't fumigate when the temperature goes up to 90 next week during the day, all right? Fumigate when it's cold. Bring in that cold temperature. And then if you have to control an insect population before selling because either it's enough to get docked or it's really infested and there's no way you're going to make any money on it unless you fumigate, okay? So fumigation is a very important part of grain storage and management. It's also the most difficult to do and the most dangerous to be involved with. Just a few slides, cleanliness. You know, this is ideal. If you get all the old grain out, and then if you can even get in the bin, open it up, clean out the wheat. This is a little extreme here. This is probably somebody for high-value seed storage. You need a bigger vacuum cleaner than that guy has. But getting everything out, the subfloor that you're looking at there is going to have a lot of dust down in there, and that's where we can use sprays or get in there and suck out the bad stuff. Sampling. Okay, here's pictures of our students doing stuff in flat storages. Not everybody can get in and do this, but if you can get any grain sample at all, either drawing it off the bottom of a hopper bin or a concrete silo, taking it from the top, sieving it into dockage sieve, and you know, in a few minutes you'll know if you have live insects or not. And just that alone, do you see live insects or not, is good monitoring for insects. We have this example. Here's some experimental bins at Oklahoma State University. They're only holding 100 bushels of grain. This is easy. Not too many people will have this, but if you have seed grain on your farm, if you have grain that you want to keep in good condition for other purposes, this ought to be easy to sample. This is more difficult to sample, okay, our picture from the beginning. It's going to cost a lot of money to set up a sampling system for insects, but if you have temperature sampling, if you have temperature cables in these silos and in that big metal bin, they should be working properly and you should use them. Unfortunately, after all the years I've been doing this, and I know my colleagues have seen it too, you visit a grain elevator and you find out, hey, do you have temperature cables? Oh yeah, we got them, no problem. I said, what's the temperature? Oh, I don't know. I haven't checked them in a couple of years. Lots of times these things can easily go into disrepair, and they're expensive to replace, but they're not too expensive to maintain. So we can push that. Notice the big metal bin on the right. That's a modern enough bin that it ought to have aeration, but unfortunately I'm looking at this, I don't see aeration on that bin. So we'll show some pictures later about proper aeration and proper management. And this is where I can take a break if anybody has questions.
Okay, well, we have one question. Why fumigation in cold temperatures versus hot temperatures? Would you like to answer that, Tom?
Yeah, well, I hope I didn't say fumigate in cold temperatures. No, no, no. Do not fumigate in cold temperatures. We're going to cover the fumigation at the last part of this webinar. The thing about fumigation is, and just like the cooling for insects, we like cool temperatures to keep the insect populations low, okay, and to stop their development if you use aeration. You do not want to fumigate at cool temperatures because the metabolism of these insects is so low, again, their activity, that they might not die. And with our main product that we're going to talk about, the pills and pellets that are aluminum phosphide, they will not react and produce the fumigant. Okay, so it's very dangerous to do that because if you go to sell that grain, you may be selling active fumigant in the grain and cause a serious problem. Um, there was some other point. Yeah. So in general, you don't want to fumigate when the grain is cold. Yeah. 90 Fahrenheit versus 50? Yeah. 50, do not fumigate the grain. The label, that's what I was going to say. The label for all of these fumigation products, do not fumigate below 40. Well, that's for lots of other reasons and more historical that it's there. But I would say under 60, you definitely don't want to fumigate. And personally, even though I don't own a grain elevator, I would not want to fumigate too much in the 70-degree weather. But if you are, you can monitor it and not sell it until you're sure that all the fumigant gas is gone. And it should do its part. A lot of, again, and where I live in Kansas, it's typical to fumigate at the end of the storage season, like right about now. And even though it's cold outside, the grain, I can almost guarantee you, is still in the 80s and 90s, maybe the 70s, and so it's still okay to fumigate. Don't fumigate in the wintertime, don't fumigate late in the fall, and really know what you're doing if you fumigate early spring or late fall.
Okay, thanks, Tom. So we have another question that came in. Do you have any idea how many on-farm bins actually use a protective insecticide on the grain?
Numbers. Okay, well, Frank Arthur will deal with that as soon as he gets on. He might add something. But, our sense is, when I've talked to farmers on farm, some of them are using protectants. However, some of them might be the older protectants that they're used to using. Malathion is still registered as a grain protectant on stored grain, and people are familiar with that. And, I've talked to folks because we have some information that insects are resistant to malathion in some cases, and that it may not be effective. But as long as nobody's complaining and they're happy with the grain after the storage, then it's all right. So the people, we would say that if you're going to use a grain protectant, there has to be a good reason. And that reason in wheat country is because they're storing their seed. All right, right? So Sarah's nodding that, yeah, I mean, that's what we're doing. Here, in corn, you're usually not storing the seed because it won't work the next season, being a hybrid. But there's other reasons. A long time ago, my colleague Phil Kenkel did some sort of survey at Oklahoma State, and a lot of people were using grain protectants, but they were relatively cheap at that time. And these days, we got some really excellent grain protectants, but you want to make a decision. If it's going to cost 5 cents a bushel, you want to make sure you're going to make money at the end of it and that there's a good reason to use it.
Okay, thanks, Tom. And another question that came in is, could you repeat the acronym for damaged corn? They said that wheat was the IDK, but what was the damaged corn?
Okay, well, I worked in Wisconsin 20 some years ago, but that's why I mentioned the acronym for corn. Let me go back to the acronym for wheat. IDK is actually a special category. It's not doesn't refer to the class or anything, but it stands for insect damage kernels. Okay, so for wheat, the Grain Inspection Service has come up with an IDK number above which it is not fit for human consumption, and that is 32 insect damage kernels per 100 grams. And if you do some math and you know how much a kernel weighs, that's about 1%. Okay, so if 1% of the wheat is damaged by an insect, it's not fit for human consumption. That's all I can tell you as a government employee. When it comes to corn, BCFM, if they still use it, stands for broken corn and fine material. Okay, that also is sort of a condition of the corn. I haven't paid attention to corn grading lately, It may or may not contribute to the grade being number 1 or number 2. But that's the thing, is if you know how to grade your grain, the way the grain inspection service would do it, and the way any elevator or any customer would do it, then you know how much your grain is worth for the short period, short answer.
Alrighty, one last question, and then we're going to move on to Frank. What is your opinion on diatomaceous earth as a pest management program?
Later. I'll tell you what, Frank's going to get into his section because he's an expert on grain protectants, and I don't want to bore you with my opinion on diatomaceous earth, so Frank will give you the official thing on that.
Okay, our next speaker is going to be Frank Arthur, and here is Frank.
Click to the next.
Yeah. Okay, I'll go ahead and try to answer the last question a little bit. A lot of the older formulations of diatomaceous earth that were around 20 or 30 years ago were not particularly effective. They caused a lot of damage to grain handling equipment. A lot of the newer formulations are better. You still have to clean the diatomaceous earth off from the wheat. The newer formulations are a bit better. People use them as pre-binning treatments. Tom and I have both done projects where we tried to treat the entire grain mass with diatomaceous earth, and it does slow down the grain going up the auger.
We broke an auger.
In fact, we broke an auger shaft one time and had to weld it back together. So I think you need to be careful with diatomaceous earth if you're using it.
But empty bins, you agree?
Yeah, empty bins are fine.
Yeah, and it never goes away. I mean, except with grain, it has residual activity for a long time.
And in some, depending on the certifier, it could be labeled as organic. So I think there's a time and a place for it in a management program.